what would be the selling price of the house given the size of the house is this. Okay. Now, what is so difficult in this? The difficult in this is that we necessarily do not know that whether it is linear or not. The second thing is we do not know that what is the scale of that linear relation that your dependent variable has on this variable, right? So we are trying to find out, assuming that there is a linear relation between this and this variable, between the output and this input variable, this variable. We are assuming that there is a linear relation and we are trying to estimate the parameters of that linear relation. Now, if there is a linear relation, right? So if I give any 2 points here, so if I give you 2 points here and here, okay? Now, if I ask you to find out the equation of the line that connects 2 points, how difficult it is. So suppose I tell you that this is the point 2, 3, this is the point 10, 7. Can you find out the equation of the line by simple coordinate geometry? And how do you remember that? So somebody is saying that my voice is not audible. Is it the case with everyone? Vishakha, you especially you are mentioning. Okay, the audio is low.
Yes, ma'am, the audio is low, but your voice is clear.
Okay, so I should be speaking a little louder. This is fine. Is this fine, Vishakha?
Yes, ma'am, fine.
Yeah, okay. So what I was saying is that given 2 points, 2, 3 and 10, 7, if we are required to find out the equation of the line between these 2 points, then what is it a difficult task? Can you find out the equation of the line?
Yes, ma'am.
Yeah, it is not difficult, right? So you simply say that it is equal to y is equal to y2 minus y1 divided by x2 minus x1. That is the slope of the equation of the line x plus c, and you find out this. You substitute any one point, and you get the value of c, and finally you have y is equal to mx plus c. Not a difficult task at all, right? So why are we saying that we have to find out the parameter, right? You take any 2 points and find out the equation of the line, right? So suppose I decide and I take these 2 points and make the line, right? Okay, what is the problem in this line? What is the problem in this line?
Ma'am, all the other points are away from that line.
Yes, absolutely, right. So this line passes through these 2 points, but it is quite away from the other points, right? And this line, and what is the requirement of a good solution? That is my first question, right? What are we looking for? We are looking for a generic model. So these are our specific instances. These are the specific instances, and we are looking for a generic line which is closer to all of them. It is not necessary that it touches n number of lines. It is not compulsory that it passes through 2 points, 5 points, 7 points, not necessary. But it is required that it is closer to most of the points, right? Or rather, we would say that something, right? So a good solution is what? A good solution is a solution which is closer to most of the point. Now that makes the problem a little tricky, right? You cannot just have an equation of the line y is equal to mx plus c crossing 2 points. You need to find out the solution which is closer to most of the point, and that too not necessarily crossing those points, rather which is closer to most of the points. That makes modeling this problem a little tricky, as well as finding out the solution tricky, right? So let us see that. As I said, that this is one of the probable solution, which is touching most of the point. But I'll say that no, that's not a great solution, because if you see these points are quite far out from the line, right? Now, so what are we looking for? We are looking for a line which has minimum distance, right? And what this line is going to help us, this line is going to help us estimate the value which we do not know. So for example, yesterday I said that if suppose I want to know that what is the price of a house, which the size of the house is 40 units, square meters as written, So if it is 60 meters, 60, then what is the price, right? So 60, the answer is given as 35, right? So answer is given as 35, right? Whereas what my system is going to estimate, my system is going to estimate somewhere here, which is around 25, right? Which is around 25. So this is my model, which is the output. If suppose I assume that this is the model, then this is going to estimate 25. And if suppose I take an input this one, right, this place, which is suppose 44, right, this is suppose 44. If I take estimate the 44 value is not given, 43 is given and others. So if suppose I try to find out for 44, I get a value which is very close to 19, right? So something which is for 44, answer is going to be 19. So this model is going to, wherever I'm looking for, if I'm looking for a housing price of a particular size, I'm going to see that where this point lies on the line and what is the corresponding value of y in this line, and that becomes my solution, right? So what is my goal? My goal is that my estimation should be as close to what is the real answer. So this is why it is known as supervised. The real answers are also given, and the answer that we are likely to get on this line are these points. So how far is the real answer from the point that my model is going to estimate, right? So these are all the points. These are all the points, and this distance is my error, right? This distance is my error. Distance of the point from the line, because this is what my system would estimate. This is what actual is given. So this is the error. This minus this gives me an error, right? So the objective of or every machine learning problem, whenever you are trying to solve, the first task is to define the objective function, right? So what is the objective of this machine learning algorithm? The objective of this machine learning algorithm is that find out the line such that this is minimized, right? The objective is that this error is minimized. So let's see that how. This is another possible solution, and this one is another solution. This looks to be the best, right? This looks to be the best. So mathematically, if you see, right, so this is what is given. So how are we going to call our values? This is going to be called as x. This is going to be called as y. This is 1, 2, 3, 4. So we are going to call every instances by its instance number, and x is the input variable, y is the output variable. Whenever I am saying y2, I am referring to value 17. Whenever I am referring to x2, I am referring to x2, I'm referring to this 37, right? So basically this y is what is the value, what is this the output variable, and the number, the subscript is the number of the instance that we are referring to. So if you see here that this yi, right, yi minus this. So what is the error? So my error is basically yi minus y cap I. Now, what is this y cap I? Y cap I is something which is the output which we get from our model. And how do am I going to get this from the model? So if I have the equation of the line as y is equal to mx plus c, what is going to be the value of y? What is going to be the value of y at x is equal to 44? So what I do, I substitute this 44 in this equation, and 44 plus c, where I already know the value of m and c, isn't it? That is what we do. So this becomes my y cap. This is the estimate, right? So I'm saying that the estimate of yi when value given is xi, right? The estimate of yi is this. What is the real value which is already given here? So I hope you understand the difference in the terminology that is being used. Yi minus y cap I and right. So that becomes my error. Now, error is error, whether it is on the positive side. So, if suppose you say about this solution, you see that the value estimated is higher and the actual value is lower. Here, the value estimated is lower and the actual value is higher. So, in this case, if I write my error as yi minus y cap, yi minus y cap, this minus this. If I write like this, then this is my error is going to be positive here, is positive here, and here the error is going to be negative. Okay, so here the error is positive, here the error is negative. If I add a positive errors, if I add a positive error and a negative error, so if I add minus 33 error, suppose this error was suppose 5 minus 5, and here the error is plus 5, this gives me a zero value, which is actually not the true indication of what the actual error is. The actual error should be the absolute value of the differences, right? So error is an error, whether you estimate it high or you estimate it low. So to avoid that, you have a square sign here, right? So mean square error, as we say. So this is what is the real value. This is what is the estimated value, and you want to square it. And summation of all of them is to be minimized, and this is what is known as my objective function. Okay. Is this clear up to this point? Am I making sense? Am I making sense up to this point?
Yes,
मैम
ma'am.
आई हैव अ डाउट
Yes, please. Yes, please.
मैम जब वहाँ पे एरर जीरो आता है तो कैन वी से इट इज एरर लाइक इफ द
That's what I'm saying. That's what I'm saying. That zero is not a true indicator of the actual error. So therefore, to avoid this situation, I'm going to square this and square this. That gives me 5 square plus 5 square is 25, which is the right estimate of the error. That's what I said.
बट मैम
Zero.
सपोज लाइक जो लाइन हमने ड्रॉ की है और
हम्म,
उस पे जितने भी पॉइंट्स आ रहे हैं
हाँ
तो
जी।
उस केस में तो एरर जीरो ही आएगा ना क्योंकि डिस्टेंस तो है ही नहीं पॉइंट्स के बीच में और
तो
लाइन
वहाँ
के
आएगा,
बीच में
तो वो तो ट्रू इंडिकेटर भी हुआ ना।
हाँ
दैट्स द ट्रू इंडिकेटर। आपका जो एरर
ओके
वैल्यू है, इट शुड ट्रूली इंडिकेट दैट हाउ मच इज द एक्चुअल एरर, है ना? अगर जीरो आ रहा है और जीरो है तो कोई दिक्कत नहीं है, पर
ओके
जीरो नहीं है और जीरो आ रहा है तो परेशानी है ना?
ओके
दैट्स
ओके
व्हाट आई
गॉट इट
सेड, इट्स नॉट द ट्रू इंडिकेटर, राइट?
ओके या
ओके।
मैम
हाँ जी, बोलिए प्लीज।
मैम ये हम लाइन ड्रॉ कर रहे हो किस बेसिस पे ड्रॉ कर रहे हैं?
अभी हम वही फाइंड आउट करेंगे कि वो उसका इक्वेशन क्या होना चाहिए। अभी हम वही फाइंड आउट करेंगे कि हमको वो लाइन कैसी देनी है कि ये वैल्यू मिनिमम हो जाए। अभी हम वहीं आ रहे हैं, बस जस्ट
ओके
कमिंग टू
ओके
दैट। पर लाइन की रिक्वायरमेंट, एक अच्छी लाइन की रिक्वायरमेंट क्या है, और रादर व्हाट इज अ requirement of a good solution? We should be clear of it. What do we want, right? And then we will zero down that okay, we want something which minimizes the error. That is what is our requirement, isn't it,
यस मैम
Dipendra?
यस मैम
Yeah, yeah. So we are trying to model that. Okay. Okay. Now, so we have to minimize this error. As I said, why are we squaring this and so on? So I said that we are going to find out the difference, square it, and then add it so that it becomes the true indicator of what the actual error is, and find out the average of it. So this average is usually m. Why do we keep 2? I'll just talk about it in a while. But for now, you understand that we have added all the differences, the square of the differences, and we are finding out the average. That is also known as mean squared error. Okay, mean because we are taking the mean squared error, and that's what we have, right? Now, there was a question by Dipendra, and he was saying that what the line should look like, right? How do we know that what is the line? So basically, what is defining a line? Line is defined by two parameters, right? Y is equal to mx plus c. For this particular topic, we are going to say that my y, or my estimate, my y cap, is going to be defined by two parameters, theta 0 and theta 1. Okay, my estimate y is defined by two parameters, theta 0 and theta 1. That is what is going to define my line, the slope and the intercept, isn't it? The slope and the intercept, right now I don't know. So if I know that what is the slope and what is the intercept, I can actually draw the line, isn't it, Dipendra?
मैम
Yeah. So we are actually trying to find out that what should be a good value of theta 0 and theta 1 such that your error is minimum. That is what is going to be our entire exercise focus too. Am I clear? Right. So what I say is rather my this objective function, which is the mean square error, is going to be a function of two values, theta 0 and theta 1, because that is what is going to change, and we are going to settle at this point, or we are going to find out the minima at minimum of this j theta 0 theta 1 and corresponding value of theta 0 and theta 1, right? तो आपको एक एग्जांपल और दे पहले बिफोर यू अंडरस्टैंड दिस. अगर हमको इफ आई हैव अ इक्वेशन एफ एक्स इज इक्वल टू एक्स क्यूब प्लस 2x plus 3x square plus 1, this is the equation of the line, right? If suppose I have to find out the minima or maximum of this equation, okay, so what do? We differentiate it, we equate it to 0, and wherever we get the value, we substitute this value in the second derivative, we find out whether it is positive or negative, and accordingly we know that this is the point of minima or maxima, and we also know that at what point did we get maxima and minima, right? So you all must be remembering the concept of maxima and minima given an equation, right? So every equation has a variable, and this variable in this case is x. And in our case, the variables are theta 0 and theta 1. So we are interested in finding out the minima position of this j theta function, and find out the point where this j theta attains the minimum value. And that point is an optimal value of theta 0 and theta 1. Do I sound convincing? Do I sound convincing?
Yes, ma'am.
Yeah? Okay, if you have any doubt at any point, please stop me there and ask me, okay? And please let me know that I need to talk about it again, okay? So what did I say? That I said this is the equation, this is the objective function, and the objective is to minimize this j theta, this mean squared error, and we need to find out that point of minima and the corresponding point and the corresponding value at that minima point for theta 0 and theta 1 is going to be an optimal value of your equation of the line. It means that this point of theta 0 and theta 1 is going to define the line which is going to be closest to most of the points in the given data set. So I'll repeat again, I'm saying that this point theta 0 and theta 1 is going to define the line which is going to be closest to all the given points in the equation. So for all given x and y, we are interested in finding out the optimal value of theta 0 and theta 1. Don't confuse yourself a lot. I'm going to work out everything here, even if it may sound a little confusion. I'm sure I'll be clearing this in the one or two slides.
Ma'am,
हाँ जी बोलें please.
theta is representing what? Theta 0 and theta 1.
You tell me, if this is the equation of the line, what is this theta 0 and theta 1 representing?
One is slope, but the second I couldn't get it.
How do you define the equation of the line?
Theta 0 is equal to origin.
Come on, it's not origin.
The equation of a line is defined by
What?
mx plus c. You have written that.
What is C? What is C?
C is any constant.
What? No, that's not constant. What is the physical? Yes, then you all need to revise your concept of coordinate geometry badly. Yeah, that's the y-intercept, isn't it? So if the equation of the line, what is the definition of y-intercept? So if the equation of the line is this, right? Your theta, your slope defines the angle that it makes with the x-axis. So this is what is theta, tan theta, and the y-intercept is this, right? This is y-intercept, or rather this is C. This is C. You remember?
So
No, you don't remember? Come on.
so the value of y cap will be same for every value.
Why? Why it will be same if your x is varying? Why y cap will be same for everything?
The line is same na for every equation.
So, but the points are different. So, for example, let me come. Okay. So, if suppose here I say that my equation of the line is y cap is equal to suppose 4 plus 3x. This is a good, this is my solution. Now put instead of x, put here 35. What will be your y cap? For x, put 35. What will be your y cap? I'm asking.
109.
Yeah. So here, if I put x, it is going to be 109, right? If I put
Yes.
37, am I going to get a different value or the same value?
Yes, different value.
Yeah, even if the equation of the line is same, you're going to get different value, isn't
So
it?
the value depends on x, not theta, na?
It depends on both, dear. X is a input. These are the parameters which are going to be the output of the learning equation, right? But at the end of it, I'm going to get one value of theta 0 and theta 1, and my x will, of course, vary.
Okay. So the value of theta 1 and theta 0 will be same for every y cap and x will differ, na?
Yes, yes.
Okay, okay.
है ना?
Okay.
Okay, right. Any other queries? Okay. So what I was saying that we need now, if at all um, so now the relevance of theta 1 you understand, the relevance of theta 0 you understand. This is the intercept, and at the end of this learning algorithm, we are interested in finding out a good value of theta 0 and theta 1. A good value of theta 0 and theta. Okay. Now, what I suggest is because you have asked some few questions, I actually feel that I'll take 2 more minutes. Just hold on. I'm going to take 2 more minutes and going to draw something for you. Oh, I'm sorry. Do you see my OneNote screen? Okay. I hope you see that. Okay.
Yes, ma'am.
Yeah. So, what we have is that our y cap is equal to theta 0 plus theta 1 x, right? So this is what is going to be our y cap, and we are interested in finding out a good solution for my theta 0 and theta 1, right? Now suppose let us for a second assume that you do not have a theta 0. It means that equation of the line passes through your origin, right? So it is either this or this or this. We actually do not know, but we are only interested in finding out only one parameter. So I'm modifying my equation of the line as theta 1 x just for a moment. Okay, I'm just modifying my equation that it is theta 1 x. So assuming that your equation that your line is always passing through the origin, the data set which is given x and y is suppose 2, 4, 3, 7. This is x, and 7, 11, 10, 17, 21, and this is 24. So these are the points that we have. So this is my x, this is my y, and I'm interested in finding out that what is this theta value that can best define this equation. Okay, that can best define this equation. Okay. Now suppose I take the value of theta 1 as 1. If I take the value of theta 1 as 1, how my, and what is going to be my j theta? My j theta 1 is going to be the actual y minus my y cap, which is equal to y minus theta 1 x. Okay, this is and square of it. Sorry. So this is going to be summation of square of all the values, and this is going to be summation of square of all the values divided by 2m. Do you get this?
Yes, ma'am.
Yeah. Okay. Now